This time we're going to solve the system by elimination. Substitution best works if you have isolation. Let's say if you have two equations, you're just kind of sitting there minding their own business. You want one of them to be isolated. Okay, so you want an isolation here. For elimination, you want both equations in standard form. So you want one to have x and y on the same side, the constant on the opposite side, and you want the other one to have the same form. Okay? So elimination, we want this type of situation. And we have that. We have the 2x plus 3y equals 13, and we also have a negative 2x plus y equals negative 1. All right, so in elimination, once you have both equations in the same form, okay, what you want to have is next find an additive inverse for either the x's or y's. Now when we say additive inverse, that's something like a 5 and a negative 5, or should I say a 5x and a negative 5x. Those are additive inverses because when you put them together, they cancel each other out. Or maybe something like a negative 3y and a positive 3y. Those are additive inverses. And even if you had z's. Oh, sorry, couldn't see that. All right, so you want something like a positive 5 and a negative 5x, or 5x and negative 5x. Those are additive inverses. Or if you had a negative 3y, you would want a positive 3y's, and those are additive inverses, and those would cancel. So let's look for additive inverses, and we have them. There's a 2x here and a negative 2x. So when you have additive inverses, we're going to combine two equations. So 2x and negative 2x makes 0, and 3y and y make 4y. 13 and negative 1 makes a 12. Okay, and now you have one variable. So we're going to take the 4y equals 12 and divide both sides by 4. This will give us y equals 3. And now we've just solved for y. Now to get the x, let's bring back one of the two equations. I think I'm going to use this one right here because it has no negatives. The fewer negatives we have to complicate things, the better. So 2x plus 3y equals 13. And we're going to substitute the y here for 3. So this will become 2x plus 3 parentheses 3 equals 13. Okay. And then we're going to turn that into a 2x plus 9 equals 13. Subtract 9 from both sides. This will give us a 2x equals 4. And I'm going to neglect writing 2x minus 4 again because we're running out of room. So divide by 2, we get x equals 2. So the solution of our system is x is 2. It's a bad looking 2. And y is going to be 3. Okay, next, system. We have a 2x plus 4y equals negative 2. And underneath we have a 4x minus 4y equals 20. And they are lined up the same way. xy constant, xy constant. And we also have additive inverses, which is great. That means we can proceed. So 2x and the 4x become 6x. These cancel. Now we have equals. And the negative 2 and the 20 become an 18. Okay. And from here, we're going to divide by 6 on both sides. And we're going to get x equals 3. Okay. So we just solve for x. Now to go get the y, we're going to use substitution. So let's use the 2x plus 4y. 2x plus 4y equals negative 2. And for the x, we're going to make that 3. So this becomes 2 times 3 plus 4y equals negative 2. 2 times 3 is 6. plus 4y equals negative 2. Okay, and subtract 6 from both sides. We end up with 4y is equal to negative 8. Divide by 4 on both sides. We end up with y equals negative 2. So we're going to say that the solution of this system is x is 3 and y is negative 2.